Hey guys, welcome back, and this week we are back on the Frankenholer, and this week we're going to finish up all of the controls. All right guys, welcome back, and if you're just catching up, this is the Frankenholer. This is my 1954 F600 truck that I have mounted onto a Toyota Coaster bus chassis. If you missed the last episode where we worked on it, I'll put a link up above so you can catch up, and like always, do the things like, subscribe, comment. That all helps out that crazy algorithm. So where we left off, I got the steering sorted last time, and this is actually all connected up and going to work quite nicely. I started mocking up the accelerator pedal, and I've got it in roughly the right place, but it's not working exactly how I want it, so I need to work out how to mount it properly and sort of get that finalised properly. Once we've done that, then I'm going to have to do something about the shifting. But first up, I think we need to get in and have a look at where we're sitting with that pedal. All right, so this is how I set up my pedal last time, and you can see here I have the full range of movement. It's in the right spot as far as where the brake is, and all that sort of situation is good. Because I had to re-angle the pedal and things like that, I don't really like where this front part of the bracket is. There's a little switch here. I'm not actually sure what that's for. I think it may be some sort of safety mechanism for the bus, to act as a bus, like with the door and things like that, because I can't think of any other reason why you'd have a switch that only activates when you press on the pedal. So it's basically like a brake switch, but on the accelerator. So I'm going to delete that and then try and make a nicer method to mount it into the footwell. All right, that is much better. Now I've got the pedal on the front of this, so it's just going to sit in a nicer location. So now let's get it back in and mock it up again and see how it goes. All right, so that was a lot of playing around, trying to get the, still trying to get the pedal in just the right spot. So it's still got enough travel before it hits the floor, but it's not sitting too high, too low. It was quite a lot of playing around, but I've got a angle bracket here that I've now welded some captive nuts onto the back of the pedal itself. So I'll be able to feed this in and then reach in and bolt the pedal in and out. Again, thinking about serviceability. And while I'm on it, World Class, as you know, has been a sponsor in doing giveaways this whole year, and this month is no exception. And they are actually giving away this month 3 of these Pro Max 350 Australian flag helmets. Yeah, very cool. There's a link in the description. Head over there and go and check out World Class. Obviously, I've been using their welders and everything for quite some time. Good stuff, and yeah, it's always a good thing to try and help out the guys who help out the channel. So check out this month's giveaway, win one of these helmets, and all right, let's see if we can get this back in the car. All right, that is looking much better. So now I have full range of movement. I'm miles off the floor. I have a nice solid base. I can unbolt it in 3 spots. I am very happy with that. We have a pedal that's going to do pedal things. So until I come back and build the firewall, that's done. Pedals are in the right spots. Steering wheel is in the right spot. Next thing I need to do is start having a look at making a gear shifter. All right, so the next thing I need to tackle is the gearbox and specifically getting a gear shifter to work. Now, getting a Land Cruiser gearbox would actually make my life really simple because the Land Cruiser gearbox, the gear shifter comes straight out of the top of the gearbox. It's a part of the casing of the gearbox, comes straight up, and then I could get a shifter mechanism come straight up and out, and it's in the right spot. I don't have a Land Cruiser gearbox, and I had a look for Land Cruiser gearboxes, and they're really expensive. And I have a perfectly good working gearbox here, and I'm not going to spend all this money just to change it over, just to save myself a little bit of work. So this is what I'm talking about. This is an 80 series gearbox, which also had a 1HZ, and there was also a 75 series that had a 1HZ. Both of those gearboxes appear, at least from the pictures I've found, to be slightly different. I may even have been able to remove the top plate off of the gearbox, but they do look different. The one on my Coaster gearbox, the top plate is actually sitting really close to the bell housing, whereas these sit nearer the back of the gearbox. They generally won't separate them, so I have to buy a whole gearbox, and that still doesn't even come with the shifter, which I have to find as well, and sourcing parts takes forever. It's so much quicker and easier to just work with what I've got. I think we can make it work with what we have here. So this is the original shifter out of the bus, and of course when this was in the bus, this was right at the front, right past the engine, and it had all of these linkages here and all of this stuff all going back to the gearbox itself to actually work it. So what I want to do is I want to see if I can cobble something together. It might not be the prettiest thing in the world, but I reckon I can make something out of what I've got left to still control the gearbox that I have without spending a whole crazy amount of money and trying to change everything over to something that I just don't have. And so the head scratching begins. There's lots of time spent sort of thinking about which direction I move the gear stick means it's going to go this way, and this lever needs to go that way, and on and on. There's a lot of thinking time required to make this all work the way I hope it should. Alright, so I've been looking at this for quite a while now. I sort of wrote my directions on how this all works when I pulled it apart, so that I know that this, you know, what this movement does and what this movement does. That's all good. I have the original gear stick here, and out the bottom of it we have an arm that's connected to this rod, and this whole system basically works, you know, left and right turns the rod, and backwards and forwards moves another lever. So that all is still something that I can potentially utilise to make a bracket for this. I've worked out that I really want the base of the gear stick up a bit higher than the gearbox, up about here, and rearwards about where my hand is here. The issue I have, I can't get this lever off. So there's a bolt here. I actually ruined the old bolt because I couldn't get it off. Basically, there's a bolt, and it looks like a pin going through to here. And no matter what I do, loosening this off and bashing into the nut to try and save the threads, but just, it will not come loose. I think it needs a press, but I don't want to pull the top of the gearbox off. I don't particularly want to put it in a press. Same with this one. This one's got the same setup, but a slightly smaller nut. Again, it doesn't want to come loose. So what I think I'm going to do is I can try and see if I'm going to be able to weld onto this. Now, it does look cast, and cast is generally quite difficult to weld, but back here, I don't know whether it is a fully cast or whether it's machine forged or what it is. So what I might do is I'm not going to use this bit. I intend to either way cut this bit off. So if I can just do a little bit of a test, weld onto this bit here and see if I can make something weld onto it that's nice and strong, and if I can, then we have a plan moving forward. All right, well, that actually welded quite easily. That's good, and this is nice and strong. I can change gears with this lever that I put in here, no problems at all. Yeah, that's not, that weld is super tough, so I don't have to worry about cutting this off now. I can cut that off shorter and put a bracket on that I want. And yeah, that will make my life so much easier. So I'm going to ignore the fact that this is unboltable and everything, and I'm just going to make my new bracket that comes off of here that I can weld on and make things work the way I want them to. All right, so this is a real brain scratcher to get the movement of the gear stick to correspond to moving these levers the direction I want. So this one here is my left and right, and this one here is the forwards and backwards. So what I've done is I've bolted up just the top part of the gear lever. This was originally a 3-piece system with lots of linkages everywhere, and it was a very complicated system that I can simplify quite a bit. By bolting this into one of the bolting points on the engine, it just gives you somewhere solid to mount it for the time being. It may not be exactly where it lives, but somewhere around there probably wouldn't hurt. Now, when I move the gear stick left and right, this arm goes up and down. What I need that to do is that arm is going to control this lever. So I need to put a plate off of here and have this having a pin coming down, so this can go, instead of going up and down, it can go left and right, and that left and right will be connected on a rod and move this lever left and right. And then when you push the gear stick backwards and forwards, it rotates this way. And what I need to do is I need to connect this arm here onto this bracket here via another one of these rods. So shouldn't be super complicated. I think I need to move this mount over this way further, but that was just a good way to let me sort of get my head around how they all need to be connected. Now I can make up the brackets that I need to hold everything in the right place, and hopefully I can get this thing to change gears. So I need to relocate the hinge bracket for the shifter. So I've found a few bolting points, a couple on the gearbox and a couple on the lifting point of the engine that I can use as solid mounting points. And now I'm using some angle iron to make a bracket to go between the two. So once everything's tacked in place, I then start dismantling my hinge bracket so that I can get everything mounted where I want it to and get the right amount of leverage for the lever arms that I'm using. So now I'm just trimming and tacking together the bits and pieces that I have around to see if I can get this to work. This is all just a demonstration of concept to start with. Next thing to modify is the arm on the shifter arm itself. Like I showed before, that was going horizontally and I need to drop down vertically. Okay, that was an insane amount of work, and I probably skipped through pretty much all of it because it's been pretty much a full day trying to suss out how to make this all work. Now, this is all just tacked together just as a proof of concept. Now, like I mentioned, this part of the gearbox, moving this backwards and forwards, this is the forwards and backwards in the gear shifter, and this part here, this is the side to side. So I have my gear shifter set up here just sitting roughly in place, and you can see as I move it side to side, it does side to side things. Now I need to kneel on the shifter so that it doesn't move, so it stays in place, but you can see that it does forward and back things when it needs to do forward and back things. and it does side-to-side things as it needs to, going through the range of gears. So despite how this looks, it is so much simpler than it used to be, because basically there was this rod here that went through to this bracket. It then went on to another 2 rods here, and then there was another 2 rods coming off that. So it was this big long linkage system that had it set up before. Now it's all set up relatively straightforward. So it doesn't look that way at the moment, but I have a brace that is going to be bolted onto this engine mount point here. I'll weld this all up and make that all stronger here. This part here is going to be welded onto that brace that goes down, and there was another couple of bolting points down here. Now with these little rods, I was thinking I could make up some sleeves. At the moment you can see I've just tacked them together on the side to side rather than putting them all in one line. And to be honest, I think I'm going to actually weld them together like that. As opposed to sleeving them, I think I can actually get so much more weld on both sides and make them super strong. They don't actually have to be one neat, even single length of rod, so I think that's probably going to be fine. So I won't lie, most of today has spent just sitting here looking at this and trying to get my head around how long each lever needs to be, because how long each one of these lever arms is directly will correspond to how much throw the gear stick needs. Everything is complicated. Everything took some thought so that I actually have a decent amount of movement in both directions to be able to do what I need to do. I think I can loosely call this good. Now it's not going to work properly until this gear stick is actually bolted in, which is going to require cutting this shaft and actually mounting it to a tunnel. It needs to be mounted solidly, but the mechanism now works as long as I translated all of the different movements correctly, and this is actually doing the gears in the correct pattern that it should be. I'm pretty sure I have, but for example, if I mount this lever down here, if I had mounted this point up here, it would have been the reverse. This gear stick needs to move forward and sit up about here at the base, which is all going to work fine for the way I've designed it. And I can just cut this rod and re-weld it together as need be. But I am very happy that I have a gear linkage system that works, that has the full range of movement, and is going to change into the gears as need be. It does work. It's just, yeah, you get the picture. All right, so now I start dismantling and I'm starting to final weld everything up so it doesn't look like a total rat's nest. Quick coat of paint makes everything look better, and then I can reassemble. All right, I'm quite happy with that. It doesn't look quite as ghetto as it did before, and it's yeah, it's going to do the job, so we can move on. All right, so we have all of the controls basically sorted. We've got all of the pedals, the steering, the shifter, all of that stuff is all organized. So the basic controls of the truck are sorted. So before I can actually build my firewall, I need to sort of work out the rest of this engine bay. So what I think I need to do is I need to get the sort of the inner wheel arches in and see if I can get them from the old truck and make them fit on the new truck. So first I have to dismantle some of the old electronics that are still on the inside of this inner guard, and then start marking out the spaces that just don't line up.
and I want to trim a little bit at a time so that I don't completely hack these things apart. I want to keep as much original metal as I can. A lot of this is still always guesswork, and just keep trimming away until it all fits.
Alright, I've got one side sort of on. It's still not completely trimmed out at the front, and I've got to trim out a little bit more to make sure there's enough suspension travel. I may actually change it. I'm not sure exactly how much I really need. It's a wheel arch to catch the muck coming off the tyre, but it's loosely in place, and as much as I can reuse, I'm going to reuse. So let's continue on, and this side I need to remove this steering rod and then see if we can get this one to fit.
So the second side is obviously a bit easier than the first because I have more of an idea of how much I need to cut straight away, so there's less sort of nibbling away at it. This side, of course, is a bit different because I have to make room for the steering box. Now I can start bolting together the rest of the front end to sort of get the dimensions all as they should be.
Alright, I am very happy with how that's come out. Obviously there was a lot of trimming on those inner guards to get them to fit, and it is all gone back together, and everything is working the way it should. Now, before I go too much further, I actually want to check and see if there's enough room in front for the radiator, but also a couple of other things. Potentially an air conditioning condenser, and yes, this thing is going to be going turbo, so we're going to need an intercooler. Alright, so we're starting to look at mounting the radiator, and the radiator was actually mounted off towards the passenger side of the original coaster, and basically one of the mounts on top of the rail, and the other mount is going to mount, mounts actually out from the rail. So I'm using the same factory mounts that I had before, and to get my measurements I used a straight edge ruler across and marked onto the chassis rail on either side to get my distances, and then eyeballed one side, got the measurements for the other, so I've got it nice and square. So I've marked out my hole. I'm going to make my mounts on this side, and hopefully it will mount up nice and square and even. Alright, so as you might have seen, I've drilled my holes and I bolted on the brackets to fit the radiator, and when I tried to fit it, I realised that the hole I drilled on this side was too far inwards, and then I started doing some measuring, and it turns out that these rails have actually pinched together about 6 millimeters as well. So before we go any further, what I think I need to do, go back and re-weld in the front brace of these frame rails. It was always the intention. I just wanted to know where everything was. Now I have my locations for everything. I can go back and do that. So that will be the next thing we need to do. But we're going to have to do that next week because we are out of time. So I think that means it's time for Fun Facts with Mrs. Jeff.
Hey guys, alongside the release of the Ford Model A in 1927 was the Ford Model AA. The The Model AA replaced the Model T as Ford's truck. It used a lot of the same components from the Ford Model A, including a 4-cylinder 40 horsepower engine, but it had a substantially reinforced chassis. It came in either a 3.3 or 4 metre wheelbase and had a fourth lower gear, known as a granny gear, to help get heavy vehicles moving. The rear ends in the early cars had wound gear differentials which limited the top speed, but the later models came with the option of a reinforced ring and pinion diff. The early cars had hand-operated wipers, but the later models had wipers that were operated by a vacuum from the inlet manifold. The Model AA was available in a variety of body styles, including the funeral coach or hearse, the ambulance, the express pickup, or the dump truck, or just available as a cab chassis so that the customer could get one of the aftermarket companies to build a bed for their needs. The Model AA's were produced all over the world, including by GAZ, or GAZ, in the USSR, who built almost 1 million between 1932 and 1950.
All right, that was a lot of head scratching in this one. I know there's going to be so many comments of people saying that I should have got a Land Cruiser gearbox or the top of one, but finding one is so difficult to find. They're expensive, and I've got something here that works, and now I can put my gear stick exactly where I want it. It's all it's all going to do the job. So yeah, we're getting there, and the front end's back on again. It's looking like
a truck.
A truck.
Yay.
Which is definitely a good morale booster for me to actually sort of see what it looks like. So yeah, we are getting there.
Yeah, so nobody wants just rusting hulks of metal.
No.
Littering
Although it does look
their
good.
yard. It looks good now. Well done, darling. Like and subscribe and let Jeff know what you're thinking. Patreon if you want to help us out. Daily, no ads. And I think that's everything.
Yep.
Yeah.
We'll see you next time.
Hopefully for further updates.
See you guys.
Hey guys, alongside the release of the it came in either 3.3 or 4 meal wheelbase. I love a 4 meal wheelbase. It came in either the rear ends had worm gear differentials. Yes. What? The rear ends in the early cars had limited gear differential because of the worms.
What?
The rear ends in the early cars had limited top speed because of the differential worms. The rear ends in the early cars had limited worms. But in the later models, they had the option of a ring and pinion diff. Reinforced. I said reinforced.
Too late.
Damn it. The rear ends in the early cars had reinforced worms.